What we're looking at today is the implications of a farmer using a higher concentration fertiliser like urea at 46% nitrogen compared with ammonium nitrate at 34.5% nitrogen. The agronomic benefits of ammonium nitrate have been fairly well publicised, but what has had less attention is the things that are advertised each week in magazines around the advantages in storage and handling and spreading of urea at the higher concentration when it comes to the practical end on farm, and how many kilograms of nutrient nitrogen, that is, a farmer can actually get in his hopper when he's going to spread, and how many journeys he might have to make for any particular field. What I want to do next is to just look at what weight of product we need with both urea and ammonium nitrate to get 1 kilogram of nutrient N. And we just need to do a little bit of maths for this one. On the left hand here I have nitram, as we said before, at 34.5% nitrogen. So here we have a ton of product, 1,000 kilograms. It's 34.5% nitrogen, so 345 kilograms out of that 1,000 is nutrient nitrogen. So what I need to do is to divide the 1,000 kilograms by 345 to get a figure of 2.9 kilograms of product, and that will contain 1 kilogram of nutrient N. I'll then go through and do the same exercise with urea, and we've got a sample of urea here at 46% nitrogen. Same calculation, 1,000 kilograms of product this time contains 460 kilograms of nitrogen. Same exercise, dividing 1,000 by 460 gets you 2.2. So in the case of urea we only need 2.2 kilograms of product, again to get 1 kilogram of nutrient N. There we have our 2.9 kilograms of ammonium nitrate. So what I want to do now is to put it into the Perspex tube here to illustrate how far up the tube it fills in terms of volume. There we have it, 1 kilogram of nutrient N as ammonium nitrate. Okay, so all I want to do now is to do the same procedure with urea, and here I'm looking for 2.2 kilograms of product, you remember, to get my 1 kilogram of nutrient N. So here's the container zeroed back again, and here I'm looking for 2.2 kilograms of product. So there I have my 2.2 kilograms of urea as product, and look at how big a volume the same kilogram of nutrient N takes with urea. So there we have it, 1 kilogram of nutrient nitrogen in both tubes, and the difference in volume between urea and ammonium nitrate to all intents and purposes is negligible. So no advantage in the higher concentration nitrogen in urea. Okay, so we're seeing here the effect of bulk density, aren't we, and the fact that a cubic metre of ammonium nitrate weighs 980 kilograms, or just under a tonne, while a cubic metre of urea weighs a lot less, in our case 730 kilograms, or under 3/4 of a tonne. So you'd see from the experiment we saw earlier that you wouldn't be able to get any more nitrogen in a spreader with urea than ammonium nitrate, but let's just follow through the calculation. And here we see a comparison between nitram and urea. Nitram with a bulk density of 980 kilograms per cubic metre, and if you do the calculation I would need 2.96 litres of product to get a kilogram of nutrient N, and if I had a 2,000 litre fertiliser hopper I'd be able to get 676 kilograms of nutrient N in that hopper. If I do the same calculation with urea at 730 kilograms per cubic metre, I would need just over 3 litres of product to get a kilogram of nutrient N. And in that same 2,000 litre hopper, I'd only be able to get 664 kilograms of nutrient N. So actually less in this case than ammonium nitrate. Now, urea samples do vary in bulk density, but the amount of nitrogen you can get in a hopper wouldn't change significantly between different samples of urea. So the bottom line really, you can't get more nitrogen in a spreader hopper with urea
than you can with ammonium nitrate, despite the change in concentration.
When we're weighing up the difference between ammonium nitrate and urea, the conclusion, as we've seen, is there is no advantage to using urea over ammonium nitrate when it comes to the spreading of it. You can't get a significantly higher amount of nitrogen in the hopper. The higher concentration on the bag is outweighed by the fact that nitram is 1/3 more dense than granular urea. The two counteract each other and no significant difference in the hopper.